In this video, I'm going to show you how to certify an ST to ST duplex fiber link using the DTX cable analyzer and the optional fiber modules. These are the Series 2 fiber modules with the interchangeable adapters. I've already changed the SC adapter to an ST adapter. That's going to allow me to do a one jumper reference and avoid any concerns about negative loss readings ending up in my test results. On the table here, you'll notice that I have inspection and cleaning equipment, and that is critical. Without inspection equipment, it really does become a crapshoot when you start doing measuring. So please have inspection equipment on hand. You may think they're clean, but you're not going to know until you visually inspect it. Also on the table here, I have my test reference cords, not patch cords, but test reference cords, or TRCs. When you're doing a measurement, specifically if you're doing it to the ISO IEC 14763-3 standard, you must use reference grade connectors on the end. That means for multi-mode, better than 0.1 dB, and for single mode, better than 0.2 dB. Now, even if you're just testing to the TIA standard, you really want to use reference grade connectors. Why? Because it gives you consistent, repeatable test results. So, you'll notice that at one end, I've got my two ST adapters. That makes sense. I'm doing an ST to ST duplex fiber link. The other end, I've got an SC and an ST, and that's why they call them hybrid test reference cords. That's going to allow me to do the one jumper reference. So, the first thing I'm going to do is connect it to the output port on the main unit. Also, on the output port fiber is this red thing, which is a mandrel. And this mandrel is critical. If you don't use a mandrel, your results are going to be pessimistic, so please use a mandrel. Then, I'm going to take the other end of this fiber and connect it directly to the remote unit. I'm not going through a bulkhead adapter, and I can do that because on the remote unit, on the input port, we've changed it from SC to ST. I got a 50-50 chance of getting this right, but because these are fluke TRCs, red is hot and black is cold. So we go from the output, which is hot, to the input, which is cold. So my black is going to go to the input port. Be gentle, find the key, push it in, and turn. I'm then going to take my other test reference cord, which again I've inspected, made sure everything's clean, connect it to the output port on the remote unit. Again, I've got my mandrel, critical, and connecting it to my main unit on the input port. And again, it's got the ST input port on there. So, which one am I going to use? I'm going to use the black one. And that chirp indicates that I got the polarity correct. It's just a question of finding the key, don't force it in, and turn. Okay, let's talk about setting up the DTX cable analyzer. So we'll rotate the delta setup, and with fiber loss highlighted, we hit the enter key, and we see our test limit is TIA. That's what I'm going to use today. If I was going to use another standard such as ISO IEC 14763-3, I would hit the enter key, F1 more, and go and select ISO. And there's my standard. Fiber type. I've got that set as OM2 at the moment. You'll notice I'm using aqua cables, which means it's OM3 fiber. So I need to change this to OM3. That's an important setting. At the bottom of your Linkware test report, you're going to see a list of supported applications for the fiber you just tested. If I'd left that at OM2 fiber, and my link was greater than 82 meters, then 10G base SR would not show up at the bottom of my Linkware test report. But by selecting OM3, as long as my link doesn't exceed 300 meters or 2.6 dB loss, actually both, then 10G base SR will show up at the bottom of the test report. Remote end setup is smart remote because I'm doing duplex testing, and bidirectional testing is set to no. Neither the TIA or ISO IEC requires bidirectional testing. However, your consultant, end user, or a cabling vendor offering the warranty may, so please check with them. Next is the adapter count, the number of adapters. This is the number of adapters added after you set the reference. We're not setting a reference through any bulkhead adapters. We're simply going to be testing a fiber link patch panel to patch panel, which has got a bulkhead adapter in one end and a bulkhead adapter in the other end. So our adapter count is 2. Changing this will change the test limit within the tester. Our number of splices is 0. Even if you're using mechanical connectors such as unicams where there's a mechanical splice inside, this remains 0. The only time you increment this is if you're doing pigtails with fusion splices, or indeed if there's a splice in the link itself. Our connector type is ST. That doesn't affect the outcome of the test result, it just affects the help screens that appear on the DTX. And then our test method, which is 1 jumper. That is an important setting if you're doing the ISO standard, because if you swapped it to 3 jumper, it would affect the test limit. In TIA, it doesn't, but it is recorded with the test result, so make sure this is set at 1 jumper. Then we go across to tab number 3, where we see the index of refraction. This is going to affect the length reported by the cable analyzer. So please go to the cabling vendor's website, download their latest data sheet, and make sure that the values on that data sheet match what's on the screen here. If it doesn't, change the values here. So I'm going to rotate my dial to special functions to set a reference. And before I do that, it's very important to mention my sources have been switched on for at least 5 minutes to stabilize. If I don't allow them to stabilize, I could end up with negative loss readings. And if your instruments were stored in a cold location, it could take more than 5 minutes to allow them to stabilize. So with set reference highlighted, I hit the enter key. It draws a picture of my setup, and I hit the test key again. And now it's going to zero out any losses on the output ports and the fiber going to the main and remote units. And it's going to come back with power values, and these are in dBm, dB milliwatts. Now, as a guide, if I'm doing 50 micron, I want this to be better than minus 24.5 dBm, where minus 22.5 is better than minus 24.5. And that appears to be the case here today. If I'm doing 62.5 micron, I want it better than minus 20 dBm. If I'm doing single mode, I want to see this better than minus 8 dBm. And noting that if you're doing single mode, you want to make sure that your test cords are laid out straight. Otherwise, you could end up with negative loss readings and pessimistic readings here, particularly at 1550 nanometers. So, that said, I F2 OK. And above the F1 key, I can actually put the length of the test cords that I'm using in here. It doesn't affect the outcome of the test result, but it will appear on the test report itself. F2 OK. And now, a step that very few people do. I want to make sure that my sources are stabilized. So, I'm going to rotate the dial to auto test and run a test. If my sources are stabilized, I should see 0 dB loss on both fibers. The input fiber noted here is the fiber going to the input port on the main unit. I hit enter and I see 0 and 0, which means that my source on the remote is stable. I then go and look at my output fiber, which is the fiber connected to the output port on the main unit, and it's also showing 0 and 0. Good, my sources are stabilized. On to the next step. Now I'm going to remove the fiber from the input port on the main unit and cap it. And also remove it from the input port on the remote unit. And again, cap it to protect it. Then, on the main unit, where the mandrel is, you will find your ST connector, black, which is cold because it's going to the input port. So I connect that in, find the key, push down, turn. I'm also going to do the same on the remote unit as well. Find the key, push down, turn. So now, my main unit, I'm presented with Duplex ST and my remote Duplex ST. So I could plug this into one end, plug this into the other end, and start testing. However, I don't know how good these test reference cords are. So what I want to do is test them, and I'm going to do that by connecting them through a bulkhead adapter. So I'm going to grab my bulkhead adapter here and hot to cold, so red to black, and then the same on the other fiber. That chirp indicates that I've got the polarity correct. So now I'm going to run an auto test, which is going to tell me how good this connection here is in the middle, and hence how good my test reference cords are. Okay, so let's run the test. Remember, ideally, I want to be around about 0.1 dB because these are multi-mode test reference cords. My input fiber is 0.03, which is excellent. And my output fiber, 0.1 and 0.11. Now, that 0.11, that's okay because we have a little bit of loss on the fiber as well to take into account when we added it to the input port. So that 0.11 is actually okay, that's acceptable. Now at this stage, it's a good idea to get the technician to save the result here, because now you have proof that your test reference cords were good at the time of measurement, and now you're going to get good, consistent readings. So now we've verified our test reference cords. I'm going to disconnect them from the bulkhead adapters, making sure that I cap them because I want to protect them, particularly if I'm walking to the other end of a building site. And now, this will be connected to the patch panel at one end, this to the patch panel at the other end, and now I'd run a test. And that is how you would successfully test an ST to ST duplex fiber link using the DTX cable analyzer with the Series 2 modules using the preferred one jumper reference method. That one jumper reference method will avoid you getting negative loss readings.